I'm hoping that you are, oh, we'll just leave that there, are able to keep track of kind of what we've talked about. We actually started chapter 6 by talking about polygons, which is what again? What's a polygon? A closed figure with sides, right? They have to be segments. And then we talked about a very specific type of polygon, which is a quadrilateral, which means that closed figure has to have 4 sides. And then we talked about a particular type of quadrilateral, the parallelogram. Okay? And we did all those properties about a parallelogram, right? Opposite angles congruent, opposite sides congruent, opposite sides parallel, all that good stuff. And now what we're going to do is go one more step and talk about a very particular type of parallelogram. Right? And so, right there, what we're going to do is kind of figure out, I'm going to give you these 5 properties today, and the key is to find out what is new for a rectangle. And what is basically just saying it's a parallelogram. Okay? And so the first one on here that you need to write down is that the opposite sides will be congruent and parallel. I could have written that in 2 steps, but I decided to write it in just one to save you some writing. Based on what we've learned, is that basically saying it's a parallelogram, or is that something very specific to the rectangle? Yeah. What do you think? Yeah, but that's just a parallelogram, right? We've done that. All it's saying is that if I had stuff over there, there you go, parallelogram, right? And any parallelogram would have those basically 2 properties, congruent and parallel. So far, we really haven't said that it's a rectangle. Okay, so we do need kind of all these properties. Okay. A good chance. Looks like everybody's got that down. And you do have a picture down at the bottom, so if you want to add stuff to your picture there, you can do whatever you want. You don't have it, it's up to you. So how about the opposite angles being congruent? And of course, you can paraphrase some of this stuff and get it so that you know what it means. Opposite angles congruent. That sure sounds like something I just said a couple minutes ago about a parallelogram. So far, I really haven't given you anything new. This is some stuff you already know. And I'm not going to put the angles congruent because of something I'm going to do a little bit later in my picture there. So how about the third one? Consecutive angles are supplementary. Now remember, that's the one that's not actually a test to see if you have a parallelogram, because you could have a trapezoid as well. So don't use that one as a test. But if you know you have a parallelogram, you know you've got consecutive angles supplementary. And of course, that means angles right next to each other will add to 180. What do you think about that one? Is that new? No, that's not new. So far, we've really well basically described a parallelogram. So nothing specific so far. Well, that's strange. We were already number 4, and there's nothing really new. Diagonals are congruent and bisect each other. Is that information about a parallelogram or information about a rectangle? Yes? Yeah, it's kind of really both, isn't it? Some of it is just about parallelograms, and there's one thing in particular that's specific to the rectangle. The stuff that we already knew were that the diagonals were going to do what? They were going to bisect each other. But the new thing is, and you might want to highlight it, diagonals will have to be congruent to each other. And what that means is if I went from basically, say, the top right to down there, if I went from there down to there, those two better be the same, right? If one of them's 20, the other one's going to be 20. But they still bisect each other as well. And so what you can add to your picture is this. What do you suppose is significant about that? In fact, it's very significant that all 4 of the pieces, all 4 of the markings are the same, right? Yes, very true. That where that X is actually for this would kind of be the center of mass, right? Yes. Okay, true. Okay. And what do we have here? Really, if you look at it, if I just trace this one here, what type of triangle is that? Isosceles. And which one does it match? Which one better it match? That one over there. How do I know it matches that one? By, without me writing anything, by, well, you could use the vertical angles, right? But this is side, side, side already. But could I say that and that? Yeah, so those two triangles are, what's that word again? Congruent, right? Those two triangles are congruent. What about the top and bottom triangle? Are they also isosceles? Are they also congruent? Yeah, ooh, this is getting interesting now. All right. I think most of you probably already know 5. That's one thing we haven't talked about yet, that you know about a rectangle already. But let's see if we can figure it out. Yeah. Yeah, they're right angles. All 4 angles will be right angles. And the angles I'm talking about are the ones kind of in the corners there. So that's what we really end up with a rectangle. So much more, a few more properties to learn. So the last one, maybe you want to just highlight the whole thing. I don't know. But it's something I think we know anyways. So really only 2 little bits of information that are new. So we found out that the diagonals being congruent and bisecting each other gives us a bunch of isosceles triangles. Well, this just gave us a whole bunch of what type of triangles? Right triangles. And they're all over the place. Right? So we've got, as I told you when we were going through those chapters that dealt with triangles, and there was a lot of them, right? The reason we have to go through them is they don't go away. Okay, triangles will stay with us all the way through geometry. And so that's why we spend so much time proving them congruent and doing all that stuff. Okay? Any questions about any of the properties, or maybe you disagree with them? Or do you think maybe there's another property we should have on it? No? Nothing? Yeah, that pretty much covers it. All right, well, let's try and figure this out here then. We've got a quadrilateral, and we're told that it's a rectangle. Awesome. Determine the value of x for each of the following. So these 4 problems are separate problems. Don't think the answer to number 1 is going to help you with, say, number 4. Okay, some are a little harder than others. Let's do one together, and then I will let you try some of them. Well, this one says that AZ has to be 13. We're doing number 1 here. And BZ is 3x minus 2. We're very lucky here that we're told it's a rectangle. Because if we were not told this was a rectangle, we wouldn't be able to do the problem. Because if it was just a parallelogram, we wouldn't know something very important, that all 4 of those are the same, right? And so we can actually do this. So those are basically the 13 and the 3x minus 2 are the 2 legs of the isosceles triangle, right? So they have to be the same. And so we would set 13 equal to 3x minus 2. And then we would solve. I'll do that over here. This we'll call this the workspace today, because I didn't leave myself a whole lot over there. So I think adding 2 seems like a very logical first step. 15 then equals 3x, because those cancel, and divide by 3. So in this problem, x better equal how much? 5, right? There it is. Now what I'm going to do, I think I've talked long enough. I'm going to let you loose on 2, 3, and 4. I'll walk around, see how you're doing, and then we'll see if we have any guest presenters today. Okay, so we at least have a guest presenter for number 2. We'll see if we can get some more volunteers for the rest of them. So, and this problem looks like x plus 5 equals 4x minus 13. All right. So do we agree that x plus 5 better equal 4x minus 13? Yeah, because it's basically the top and the bottom, right? And then it looks like subtracted x from both sides and added 13 to both sides and got that x should be 6. Let's have you stand up if you agree with x equals 6. What's funny is at that point, once almost everybody stands up, even if you didn't have 6, you're going to stand up anyway, right? But yes, x equals 6 is correct. Very good. And now stay standing if you would like to try number 3. Ooh, yeah, we got a few here. Let's go with right here. And I won't say the name because we don't need it to get out on the recordings, right? Unless you really want it out there, but I don't know. So number 3. So let's see, DCB better be 3x minus 45. There we go, all right. So 3x minus 45. And it's equaling something. Apparently 90. All right, yeah, get x alone, get that 45 out of there. All right, good. Oh, there it is. I'll put it over there. So x is going to equal, it's okay. I think the computers in general today have been very temperamental. I don't know if you've caught it in any of your other classes, but. So apparently x equals 45. So he set 3x minus 45 equal to 90. Do we know that for sure? Is it going to equal 90? Yeah, it has to, right? Because we know it's a rectangle, so that does have to be a right angle, right? That DCB there. And so that is correct. X equals 45. Now, there are a lot of strategies to number 4. And any of them work. Anybody brave enough to give it a shot? Go ahead. And if somebody else has a different strategy, you can always show it after the first presenter. Or I can show you another one after the first one. Okay, so he's going. Okay, that's a 3 right there, this person says. And, isosceles triangle, so that makes sense. Yep, 37, 37. Oh, 106, okay, because that'd be 74 if you add them together, right? And you got 74 over there. There it is, 74, right? Yep. So BZC would be 74, according to this presenter. All right. If you agree with 74, stick your left leg out into the aisle. Yes, try not to hit your knee when you do it. That might hurt. Okay. Yes, it is 74. Did anybody else have a different strategy? There is another one. Yes, and you can either come up or just tell me what you did. Okay. So you put an X like right here. Okay. Oh, okay. So you found out that this was 53, kind of doing it this way because you knew it was 90. Okay. And then what'd you do? Okay, so she went basically to the other triangle, right? And so 53, and that's 106, right? So then you get 74 here, and then how do we know that X over there is 74? They're vertical, right? So that's good. That's a very good strategy. Did anybody have another one? So that's the beauty of this problem. It's not easy, but there's lots of ways you can do it. Here's how I actually would have looked at it. I would have looked at it another way. I would have said that's 37, although it comes very close to the last one we just had. There's 90, right? So this one down here has to be 53 because it's a big red triangle, right? And then this one has to be 53, making this one 74. They all work, right? So very good. All right. Let's try a few more that are maybe just a little bit different and see if we're doing good here. So once again, we know we have a rectangle. Be very careful with that. I might try and get tricky with you and then tell you every once in a while that all you have is a parallelogram. Okay, so maybe you can't even do some of the problems. So be very careful. It's saying du is 26. Got it. 26. And QP, where's that? Here it is 2x plus 7. Well, we can actually find out how long QP has to be, right? How long does QP have to be? Has to be 13, right? You get that because all of these have to be the same in a rectangle. And so if this one's 26 total, it's 13, 13, 13, you get the idea. And so on this one, 2x plus 7 has to equal 13 because they're in the same location. And so you subtract 7, so 2x equals 6, divide by 2, x is 3. Okay. So that one wasn't too bad, right? It just, I gave you the entire diagonal to see if perhaps that would confuse you. Okay. Any questions on that? All right. Number 6 is one of the potentially harder ones. So let's see if you can help me with this one. Angle 4, where is that? Here it is 6x minus 16. And angle 2, where's that? There it is 2x plus 4. Those two angles seem to have very little to do with each other. There are quite a few strategies, but there is one that is definitely quicker than the rest. And I was very impressed last period how quickly they came up with this idea. Yes? Yes, and that's the quick way to do it. We can write 2x plus 4 down here as well, right? Because of the isosceles idea, right? And look at that. Angle 4 happens to be an exterior angle of that triangle. Remember, 2 remote interior will add to the exterior? So you can take, as this person said, 2 and 3, add it together, and it will equal where 4 is, right? They have to add together. So this takes a little bit of work. So we have to add 2x plus 4 plus 2x plus 4. That's angles basically 2 and 3, right? And it has to equal the exterior angle out there, which is 6x minus 16. Again, this isn't the only way, but probably one of the quicker ones. Watch out your algebra. Again, I see some crazy things at this point. You know, people try and subtract 2x from both of these, and they go away, and it's just weird. All right? So these two can be put together because they're both on the left side of the equal sign, so that's 4x. These two 4's can also be put together, so that's 8. Equals 6x minus 16. Subtract 4x. These cancel. 8 equals 2x minus 16. Add 16. Sorry if I'm going too fast. 24 equals 2x. Just let me know if I need to slow down. X is 12. That was kind of a tough one. A lot of algebra there. Any questions on that one? No? Yeah, we're running out of room, so I'm just going to put this one up there so that you can see it in the back of the room. All right, on this one, where's 3? There it is. 70 minus 4x is that angle. And 6 is 18x minus 8. Any strategies from anybody here? Yes? Okay, and how did you come to that conclusion? You can actually come to that conclusion 2 different ways. This person said that angle 6 and angle 3 have to add to 90. Yes? Yep, so this person went with the idea that there's this really big triangle here, right? And 90 has been used up, and those other 2 green ones make up the rest of it. And so those other 2 better add to 90, right? Because we need 180 total. Okay, so that's one way of coming up with that fact. Is there another way of coming up with that fact? Anybody have one? Again, I'm trying to get you to think differently, not always the same. Okay, here's another way. Parallel lines. Cut by a transversal. I could put 18x minus 8 down here because they are alternate interior. Those 2 then have to add to be 90, right? So it works either way. So let's actually do that. 18x minus 8 plus 70 minus 4x does have to equal 90. Why don't you take a second and solve that, and then we'll come back. Do you think it would have worked if I would have set them equal to each other? You think it would have worked? No. Could it have worked depending on the problem? Yeah, but they'd both have to be 45, right? And we don't know that. Right? So what do we got here? The 18x minus 4x. Some people mess up and tell me that's 22x. It's not. It's 14x, right? Ooh, some people really, a lot of people have messed that one up in the past. It's really 70 minus 8, so it's 62, right? So subtract 62. Oh, you got to borrow. 28. X equals. Ooh. Do we have a discrepancy somewhere, perhaps? Well, then you must have made another mistake somewhere else that canceled it out. I don't know. Yeah, that shouldn't happen. I don't know. Maybe in your head you still subtracted right or something. Oh. Well, maybe you subtracted 52 wrong from 90 and still got 28. So maybe, I don't know. Are there any questions on the rectangle? Remember, the two key ones are probably, whoops. Now I'm really messing up. Are that the diagonals are congruent, that's new, and all four angles do have to be right angles. So watch out for the isosceles triangles and watch out for the right triangles, because now you know you've got them. Okay?